Combination
on
of
an inclined
springs.
plane. Now remember this diagram, you remember this diagram from the inclined plane which we learned long time ago. But it's exactly the same. Mg sine theta will be balanced by the normal reaction. The only force which is acting along the incline is mg sine theta acting downwards. So let's see F equals mg sine theta. So F is also equal to negative kx. So we can say negative kx equals mg sine theta. So let's derive an equation for the time period. So we know F equals negative kx. F is also equal to m times d square x over dt square. So we can replace that by m times d square x over dt square equals negative kx, or m times d square x over dt square plus kx equals 0. I can rewrite it as d square x over dt square plus k over m x equals 0. Again we can rewrite this as d square x over dt square plus k over m x equals 0. K over m is omega square. So d, d square x over dt square plus omega square x equals 0. So what is omega here now? Square root of k over m. So it looks exactly like the if the spring is in a horizontal plane or in a vertical plane, the or an inclined plane, the time period t will be 2 pi over omega. That will be 2 pi into square root of m over k. So that does not change. The time period of a pendulum, whatever the orientation it is, does not change. So if the pendulum, if the the spring is this way, or the spring is horizontal, or the spring is vertical, the time period remains the same as long as the mass and k remains the same. So only thing which change will be the extension. F is negative kx. So here F will be mg sine theta. So that's the only thing which will change when the spring is on the inclined plane.